The Chevron Richmond Refinery lies approximately 10 miles northeast of San Francisco in California's Contra Costa County. The 2,900-acre facility was initially established in 1902 and primarily makes transportation fuels, such as gasoline and diesel, as well as lube oils. The refinery can process up to 250,000 barrels of crude oil per day. The first step of the refining process takes place in the crude unit, where crude oil is cleaned and heated before entering the distillation tower. Inside the tower, the crude oil is boiled. The vapor then condenses into various liquid hydrocarbon fractions, or streams, including jet fuel, diesel, and gas oil. The different streams exit the distillation tower through separate pipes or side cuts that lead to other sections of the refinery. On August 6, 2012, the crude unit was operating normally. Around 3:50 that afternoon, an operator was performing a routine check when he noticed a small puddle on the ground near the distillation tower. The liquid appeared to be dripping from an 8-inch insulated pipe 14 feet overhead. The leaking pipe was a section of the tower's number 4 side cut line, which operated at a temperature of 640 degrees Fahrenheit and contained light gas oil, a combustible liquid similar to diesel fuel. Chevron inspectors knew that over the years, the walls of the number 4 side cut had thinned due to corrosion, but they did not realize how close this particular segment was to failure. There was no shutoff valve between the pipe and the distillation tower, and no way to isolate the leak. The head operator was called to the scene. Although he believed the situation was serious, he did not believe the small leak warranted immediately shutting down the unit and stopping production. Following Chevron's standard practice for responding to hazardous leaks, refinery firefighters were sent to the scene. A number of managers, engineers, and technicians gathered there informally to assess the problem. The group discussed a recommendation from an operator to shut down the unit, but they decided to first try to pinpoint the leak by removing insulation from the pipe while the crude unit was still running. They hoped they could stop the leak with a temporary metal fitting known as a clamp. A Chevron firefighter tried using a pike pole to hook and pull away the insulation, but this poking action was deemed too dangerous because it was moving the pipe. The CSB later found that the tip of the pike likely caused a small puncture in the already thinned pipe. As the unit continued to operate, workers assembled scaffolding directly beneath the leaking pipe. 2 firefighters then used a hook to remove the insulation from the pipe. As they were working, hydrocarbon vapor began to flow out from underneath the insulation. The 2 firefighters backed away from the growing vapor cloud. As the hot vapor mixed with air, it ignited. That fire was quickly put out, and the 2 firefighters immediately climbed down off the scaffolding. But the exact location of the leak was still obscured by the remaining insulation and firefighting water. So the Chevron firefighters attempted to strip the insulation off the pipe with high-pressure water. But the leak suddenly worsened, and hot hydrocarbon liquid started to spray out of the pipe. A decision was finally made to begin an emergency shutdown of the crude unit. But it was too late. Suddenly, the pipe ripped open. A vapor cloud formed and rapidly expanded as the large inventory of hydrocarbons in the distillation tower started to vent through the ruptured pipe. The vapor cloud immediately spread over hundreds of feet, engulfing all 19 people who had gathered nearby. The firefighters and operators struggled to escape through the dense hydrocarbon cloud, unable to see. They had to feel their way out, some on their hands and knees. At approximately 6:30 p.m., 2 minutes after the huge vapor cloud formed, the hydrocarbons ignited. One firefighter was trapped inside a fire engine when it was suddenly engulfed in flames. He radioed for help.
Mayday, mayday, mayday! This is Phone 60.
But when he received no response, he assumed everyone else was dead. To escape the inferno, he fled through what witnesses described as a wall of fire. Fortunately, all the workers would eventually flee to safety, and there were no fatalities. The towering white vapor cloud could be seen as far away as San Francisco on the unusually clear August day. After the ignition, a dense plume of black smoke formed and drifted away from the refinery. The fire continued burning for hours. Over the succeeding days, more than 15,000 people sought medical treatment at nearby hospitals for breathing problems and other symptoms. During its investigation, the CSB determined that the carbon steel pipe installed in 1976 had thinned to the point of failure from an effect known as sulfidation corrosion. Carbon steel piping is particularly susceptible to this type of corrosion, which occurs over time when the steel is exposed to sulfur-containing hydrocarbons at high temperatures. Steel piping that happens to be low in the element silicon corrodes especially quickly. The CSB learned that sulfidation corrosion had caused a major failure at Chevron's refinery in Salt Lake City, Utah, in 2002. Chevron then performed an enhanced inspection of the number 4 side-cut pipe at the Richmond refinery. It revealed accelerated thinning in the piping section that would ultimately fail in 2012. Replacement was recommended, but this did not occur, and the section of piping was never inspected again. In 2009, Chevron experts recommended that every segment of high-risk carbon steel piping be inspected for corrosion. However, this was not done. During a maintenance turnaround of the crude unit in 2011, Chevron inspectors examined some, but not all, locations along the number 4 side cut and found significant thinning. Some sections were replaced, but managers decided that the line was thick enough to stay in service and that an overall replacement could wait up to 5 more years. According to CSB investigators, a key lesson is that each and every segment of the piping should have been inspected. Most importantly, the pipe should have been replaced much earlier with an inherently safer corrosion-resistant alloy. The CSB also concluded that had the crude unit been shut down when the leak was first noticed, the massive fire likely would not have occurred. The 19 workers would never have been endangered, and the community would have been protected. For more information on the CSB Chevron investigation, please visit csb.gov.
Ground monitor, we're going to supply from this hydrant. We got to supply that ground monitor with our 5-inch. Oh, okay. I see it. All right, so you may want to add back in. We're going to back in.